The binomial theorem is what we're interested in, and that is the binomial theorem. 1 plus x to the power of n is nc0 plus nc1x plus nc2x squared, and so on and so on and so on, up to the very last term, ncn xn. So in the middle there I've just put a general term, nck x to the power of k, which in some notation I could write that way, and that saves me writing all the terms out. I'll just the sum of the general term going from, well, my first term will be when k equals 0, and my last term will be when k equals n. And of course, nck is our binomial coefficient, which is what we saw in combinatorics of n factorial and k factorial, n minus k factorial. And note, you will always end up with n plus 1 terms in the expansion. So remember, you're starting at 0. So you'll end up with n plus 1 terms. Now that's very limiting, so we can extend that to all sorts of ones rather than just having 1 and x. But the binomial theorem technically is just 1 plus x. But we extend it through to have a plus b to the power of n. And so our general term is just the power of a and the power of b. I always make the second one to the power of k, so b to the power of k, and then the first one, well, those two powers have to add up to be the power of the binomial, so n minus k. A reminder, 11c4, we'll just do this one as an example. If we had to work it out just using factorials, 11 factorial and 4 factorial, 7 factorial, we would roll out the 11 factorial so that the 7 factorial cancels, and we'd be left with 11 times 10 times 9 times 8 over 4 times 3 times 2 times 1. There is cancelling. 4 2s are 8, and 3 goes into 9 3 times, 330. And you might be thinking, well, that's just silly, I'd just use my calculator. But of course, in questions where we're not using a number but using pronumerals, we need to know that definition so we can play with the binomial. So find the value of n. So that nc5 is equal to nc8. That's basically using that property of Pascal's triangle, which said, hey, it's symmetric. So it's coming from the same row, n, that's the row we're trying to find. We know these two numbers would add up to give n. The two powers would add up to give n. n must be 13. I've written it as 8 equals n minus 5 to get n equals 13, but basically we say, hey, these two numbers have to add up to give n. This one here uses the property of how we get each number in the row, and we add the two numbers in the row above. And so here I've got 7 and 8 giving me the 8th one, so n must be the row above. Okay? So it's coming from that property, which means the row above, well, that would be n is 19. If I have to find the 5th term in this expansion, we don't want to waste time expanding the whole thing out. We just say, okay, well, there's my general term. Now notice how I write my general term. I always call it term k plus 1. And the reason I do that is because the first term is when the power is 0. And I kind of find it funny if you say the 0th term. It doesn't make sense to me. I'd say the first term. So I always call it term k plus 1. Okay, it'd be the first term when I substitute in k equals 0. But other than that, there's my binomial coefficient, 11ck. The second one I've made to the power of k, and then therefore the first one, 5a, must be 11 minus k. We want the 5th term. So k would equal 4 for this one. Subbing that in, and there's my term. Well, that's an unsimplified form of the term. If we want to actually work out this number, it's quite a big number, because we'd be saying 330 times 78,125 times 81. It's a very large number. Sometimes we just leave them as unsimplified answers because they tend to be such large numbers. When they're not large numbers, fair enough, we'll work out what the number actually is. Find the term independent in this expression. Okay, so again, I'll write out the general term, independent. Well, that means there's no x in the term. Or another way of saying that, it's the term with x to the power of 0, because x to the power of 0 would be 1. I'm not really worried about the x values, because it's the term independent, but I need them to work out which term I'm looking for. So this, starting off, I don't worry about the coefficients. I'm just looking at the x's. So I've got x squared to the power of 9 minus k, x to the negative 1, because it's on the bottom of the fraction, to the power of k, and I want that to give me x to the power of 0. Playing with the powers, we end up k equals 6. Now that I know that, we can go back and put that into the coefficient. So there's my term. It's the 7th term, and I've left it as unsimplified. We're going to find the ratio of the coefficients for x to the power of 7 and x to the power of 5 in this expansion. So again, I'll need to know what the general term is. But I just want the ratio of the coefficients. So the coefficient of x to the 7 to the coefficient of x to the power of 5. So I haven't worried about putting x in this ratio, just the coefficients. 15c7 2 to the power of 7 over 15c5 2 to the power of 5. And this is where using the factorials can make it a little bit quicker because the 15 factorial is going to cancel straight away. 8 factorial will cancel into the 10 factorial, and the 5 factorial will cancel into the 7 factorial, leaving me with that. 60 over 7. Yeah, over 7. So 15c and 15e.